So on, you guys don't have this sheet, but or this part of the notes, it's not that huge, it's not that overly important. What we did on Tuesday is we added, subtracted, and multiplied. We did those three operations with polynomials. Y'all have done that for the most part. Multiplying, we distribute. Addition, we combine like terms. Subtraction, we combine like terms. Now to divide polynomials, when we divide two polynomial functions, we're going to get a quotient, the whole part, the whole number that comes out, the whole expression that's going to come out, and then we have the remainder over what we're dividing by. That's our R of X. This here is just the general way to write any division is going to come in this form. Now it can be that R of X is 0, which means we don't write the remainder at all. Because if there is no remainder, we don't write a remainder. Okay? So we're going to do long division. So we're going to have our division symbol. Depending on the teacher, because I think I've heard that it's been called a house, a garage. It's been given all sorts of different names for this, yes? Long division symbol. I have not looked up and seen what the actual name of this is, but this is what we're starting with. All right? And what's being divided, the x cubed minus x squared plus 2x plus x is going to go inside. Now, if there's any terms missing, we fill them in as 0 times that term. So the biggest term we have is x cubed, which means I need an x squared term, I need an x term, and I need a constant term. Since x cubed is the biggest term, so we need cubed, squared, first power constant. Does that make sense? Yep. And if we didn't have an x squared term, we're going to fill it in as plus 0x squared, or plus 0x. On the outside, we put what we're dividing it by, and if it's missing any terms, we fill them in as 0 times that term. Really, that's holding in as a placeholder so that we make sure we're combining like terms. We're not trying to add or subtract terms that aren't the same. And our answer is going to go on top of this here. Now, when we did long division, we tried to see what times our number gave us the first 2 digits, the first 3 digits. Here, we're trying to eliminate that first term. And the way I've done it for years is we tried to see what times x gives us x cubed and try to think of it that way. I was looking back at it because I know for some that's hard to try to wrap our head around and think about, especially if the number outside, that x is say 2x, and we're trying to see what times 2x gives us 3x squared. Because if we're looking at, this here is not too bad, but if we're trying to see what times 2x is 3x squared, it gets it to be a little difficult because now we're having to deal with fractions and different numbers. Looked into it this morning. The best way, I think this is a great way to do it, we take the biggest term inside and divide it by the biggest term outside. So the biggest term inside right now is x cubed, biggest term outside is x. So what is x cubed divided by x? It would be x squared. And that's our first part of the answer, because x, what times x is x cubed? Well, that would be x squared, because x squared times x is indeed x cubed. And this dividing method actually works every single time, no matter what that big first term is and the other term is. And once we find this term, we're going to multiply it by what's outside, our x plus 1. So we're going to do x squared times x plus 1. X squared times x is, lo and behold, x cubed. And x squared times positive 1 is x squared. X cubed plus. Because what we want to have happen is we want that first term to cancel out. We want it to become 0. So we need it to be the same. We need it to match up. Questions on this so far? And if you remember back to long division, because once we got to this point, we would subtract. We're going to subtract the two from each other. And x cubed minus x cubed is 0. 1 minus 1 is 0, yes? Negative x squared minus x squared. Negative x squared minus x squared. Negative 1 minus 1 is negative 2 x squared. Questions on this here? Once we finish subtracting, we bring the next term down. Because outside I have two terms, so I need at least two terms there. I need two terms to two terms. Are you ready for the next step? We repeat what we just did again. So we take the biggest term inside, which is now what? Negative 2x squared, and divide it by the term outside, which is just x. Well, 2 over 1, even though it's not written, it's understood to be 1, the 2 is just going to stay there. Because really what we're dividing is the x squared over x, and x squared divided by x is x. So our next part of our answer would be negative 2x. And again, just like we did with x squared, we're going to take the negative 2x and multiply it by our x plus 1. To find out what we put underneath it. Negative 2x times x is negative 2x squared, which realistically that's what we want. We want it to match up with that first term underneath. 2x times positive 1 is going to be negative 2x. And then we're going to subtract. Negative 2x squared minus negative 2x squared. Negative 2 minus negative 2 is 0. Because it'd be really negative 2, the negative and negative, make a plus, so we're really negative 2 plus 2, which is indeed 0. 2x minus negative 2x. Well, again, the negative and negative make a plus. And 2x plus 2x is 4x. Questions on this here before we start the last step? So we're going to do it again. 4x over x. The biggest term that we have now is 4x. We're going to put it over x. Really, kind of, as I've done this in years past, what times x is 4x? Well, 4x divided by x. X divided by x is 1, so we really have 1 times 4, or just 4. Because what times x is 4x? Well, that'd just be positive 4. Questions on this here? Okay. Now we're going to multiply again. We're going to say 4 times x plus 1. Well, 4 times x is 4x. 4 times 1 is plus 4. And then we will subtract. 4x minus 4x is 0. 8 minus 4 is 4. Excuse me. Do we have another number to bring down? No, that's it, right? How many numbers do we have on bottom left over? 1, yes? How many terms do we have outside the division symbol? 2, we're done. Because when the number of terms down here is less than the number of terms here, we are done. when the degree of the remainder is smaller than the degree of what we're dividing it by, we are done. So what we have as part of our answers, we have x squared minus 2x plus 4 plus our remainder, which is 4, yes? When we dealt long with division, it's been a while, we put the remainder amount over the number we were dividing it by, yes? Here we don't have a number, we have what? An expression, x plus 1. So it'd just be 4 over x plus 1. I will say this here, if you add anything, if for some reason we had, say, x squared plus 1, and we have to fill in a 0x, when you put the remainder, you don't have to put 0x in. If at any of the spots you end up with 0x, 0x squared, any of those, we pull all those back out. We just use them as the steps and as the parts to help fill in the blanks and hold a spot. But once we get to our final answer, we pull those back out. Does that make sense? Questions on this here? Are you ready for the next one? So we want to divide 2x to the fourth plus 3x cubed plus 5x minus 1 by x squared plus 3x plus 2. So we'll put our division symbol and start filling in our spots inside. So we have 2x to the fourth plus 3x cubed plus, wait a minute, do we have an x squared term? No. So we're going to fill it in as 0x squared. If we have any terms missing in either one of the two, we want to fill it in as 0 times that term. Even if it's outside, having 0x doesn't make a difference. We still want to fill it in as we multiply, as we do those steps, because it's still going to be 0x squared or 0x, or we still want it there just to keep track of a spot. Questions on the setup? We notice a lot of this is just repeated steps over and over again. Because our first thing we're going to do is what? Our biggest term divided by our first term, 2x to the fourth over x squared. Well, 2x to the fourth divided by x squared, well, our x to the fourth over x squared, when we divide like bases, we subtract the exponents. So x to the fourth divided by x squared, like bases, 4 minus 2 is 2. And we would still have our 2. I put that first part of our answer, because that first part of our answer is going to be 2x squared, I put it over the x squared term, just to help us keep things lined up. Next thing we have to do is take 2x squared and multiply it by what we're dividing this by, which would be x squared plus 3x plus 2. 2x squared times x squared is going to be 2x to the fourth. 2x squared times 3x, 2 times 3 is positive 6. And x squared times x is x cubed. And lastly, 2x squared times 2 is going to be plus 4x squared. Questions on any of this so far? We good with all these steps so far? Then we subtract. We always subtract with long division. 2x to the fourth minus 2x to the fourth is 0. because we want that first term to cancel. Now, if it works out that the first term and second term cancel, that's fine. If all three cancel, that's fine. We just keep moving forward. 3x cubed minus 6x cubed. 3 minus 6 would be negative 3x cubed. 0x squared minus 4x squared would be negative 4x squared. Questions on this here? Then our next step would be to bring the next term down, yes? Because we have three terms outside, so underneath that line, I need how many terms? 3, yes? If we wanted to, and it's happened that the x cubed term became 0, I can get rid of it. Well, now I only have one, drop one, I only have 2, so that means I have to bring the other one down. We have 0 for that. Repeat the process. We good? Do?
I think yes, it is too much.
Not too bad. You've probably done it in a different way. Negative 3x cubed over x squared, well, x cubed over x squared would be x. Negative 3 over 1 is just negative 3. Negative 3x cubed divided by x squared is going to be negative 3x. Then we have to multiply through to know what goes underneath. Negative 3x times x squared is negative 3x cubed. Negative 3x times 3x is going to be negative 9x squared. And negative 3x times positive 2 is going to be negative 6x. And then we would subtract. Negative 3x cubed minus negative 3x cubed, negative 3 minus negative 3 is 0. If you're not sure with your subtracting negatives, likely negative 3 minus, we can plug the coefficients into the calculator. It'll do it for us. It won't do the variables, but we can do the coefficients, our numbers in front of the variables. If we look at the next one, negative 4x squared minus negative 9x squared, negative 4 minus negative 9. Well, the negative and negative make a plus. So negative 4 plus 9 is going to be 5. So in this case, 5x squared. 5x minus negative 6x, well, the negative and negative make a plus. Telling us that we really have 5x plus 6x, giving us 11x. And lastly, we bring down the minus 1. Questions on this so far? And lastly, we would do 5x squared divided by x squared. Anything divided by itself is 1, yes? So the x squared and x squared would simplify to 1. Really telling us that we have positive 5 times 1, which is just 5. If the 5 wasn't there, x squared divided by x squared would just be 1. So telling us that our last number is plus 5. So lastly, we need to do 5 times x squared plus 3x plus 2. Nope. Those numbers aren't right. Because if we multiply it out, 5 times x squared is 5x squared. 5 times 3x is going to be 15x, and 5 times 2 is going to give us 10. And then we're going to subtract, yes? 5x squared minus 5x squared is 0. 11x minus 15x, 11 minus 15 would be negative 4x. Negative 1 minus 10 is going to be negative 11. We don't have any other numbers to bring down. Also, if we notice that the degree of the denominator, or degree of what we have left, the negative 4x minus 11, is now less than what we're dividing it by, because it's now degree 1. What we're dividing by is degree 2. We're done. So we just have to put because that's our remainder. We put it over what it's divided by right next to our answer. If you need to, write it out underneath it or away from it. You can do that too. Questions on anything we've done so far? Do we feel like we've starting to got the hang of this? Yes? Okay. All right. So if we feel comfortable, I'm gonna jump ahead of you. Because I think we feel comfortable with this, yes? Why don't we jump to D? Yes. Second to last problem. 2x to the fifth plus x to the fourth minus 15x cubed minus 2x squared plus 10x minus 24. So we're going to start off by taking our 2x to the fifth and dividing it by x squared. Well, the 2 will still be there. X to the fifth divided by x squared is going to be x to the third. I don't know if you've noticed so far, whatever we start with, the term after is going to be an x squared, and then x, and then constant term, isn't it? That's why I like lining them up, because it's going to end up working out that way. Now, one of them might end up being 0, and if that's the case, 0x cubed, we can just get rid of it. Now, at this point here, we're going to take that term we got, that 2x cubed, and multiply it by our x squared minus x minus 4. 2x cubed times x squared is going to be 2x to the fifth. 2x cubed times negative x is going to be negative 2x to the fourth. And 2x cubed times negative 4 is going to be negative 2x, or 8x cubed. So 2x to the 5th minus 2x to the 4th minus 8x cubed. Now, if you feel very comfortable with these multiplications, you don't necessarily have to write those scratch steps out. But if you mix one of these numbers up, it's going to mess the whole thing up. But if you feel comfortable with it, go with it. Now, 2x to the 5th minus 2x to the 5th. 2 minus 2 will indeed give us 0. X to the 4th minus negative 2x to the 4th. Negative, negative make a positive, telling us that we have 3x to the 4th. Negative 15x cubed minus negative 8x cubed. Again, the negative and negative make a positive. Negative 15 plus 8 is going to be negative 7x cubed. We bring down our next term. Three x to the 4th over x squared. 3x to the 4th divided by x squared. 3 over 1 is just going to be 3. X to the 4th over x squared is going to be x squared. So we have plus 3x squared. And again, like before, we're going to distribute this out. 3x squared times x squared is 3x to the 4th. 3x squared times negative x is negative 3x cubed. And 3x squared times negative 4 will be negative 12x squared. And then, lo and behold, we're going to subtract. 3x to the 4th minus 3x to the 4th is 0. Negative 7x cubed minus negative 3x cubed, well, the negative and negative will make a positive, telling us that we have negative 4x cubed. Negative, negative make a positive, plus 10x squared. Plus 10x. Now we're going to, again, repeat the process again. So we take negative 4x cubed and divide it by our x squared, giving us negative 4x. And I'll write it up there in a second. This time we're going to multiply through by negative 4x. Negative 4x times x squared is going to be negative 4x cubed. Negative 4x times negative 4x is plus 4x. And negative 4x times negative 4 squared is going to be plus 16x. Cubed. And before I go too much farther, and again, we're going to subtract negative 4x cubed minus negative 4x cubed. Negative 4 minus negative 4 is indeed 0. 10x squared minus 4x squared, it should be a square, is 6x squared. That's fine. 10x minus 16x is going to be negative 6x. And then we bring down the negative 24, yes? We got to do it one more time, then we're done. So to see what goes on top, what we need to multiply by, we're going to take 6x squared and divide it by x squared, yes? 6x squared divided by x squared is 6. I got ahead of myself because that's not supposed to be 24. Because if we distribute the 6 through, like we've been doing with all the rest, we get 6 times x squared is 6x squared, yes? 6 times negative x is negative 6x. 6 times negative 4 is negative 24. Before I get too far, we'll put the plus 6 up here. 6x squared minus 6x squared is 0, yes? We've had that all the way up to this on all of them. Let's look at the next one. Negative 6x minus negative 6x is 0. That's fine. Negative 24 minus negative 24. So our remainder is 0, yes? Which means it divides evenly. If there is no remainder, I'm not going to put plus 0 over x squared minus x minus 4. That's just a 0. Questions? We feel good with this here. The process as a whole is very repetitive. The steps from one part to the next are nice. We take it one step at a time. We get to the end. The steps are not bad. The overall process can take a while, yes? One of the interesting things I'll point out, I forgot to point it out, 4th hour, your answer's degree is the degree that we started with minus the degree we're dividing by. Because when we divide like bases, we subtract the exponents, yes? We're dividing polynomials, we'll subtract the degrees. The degree that we started with was a degree 5, yes? And we're dividing it by a degree 2. 5 minus 2 is 3, yes? What's the degree of our answer? 3, isn't it? That's how it will work that way every single time. It's a way to kind of check and make sure, is this the right answer? Yes. It gives me a way to verify. Questions on this here? So, we're going to do this one here, and this one here is actually going to be way faster than the last one. Which kind of seems odd because, again, we're degree, it is a degree 4, not a degree 5, so that should be one less step. But it's actually going to be a lot faster. Probably the fastest one we've done today. So to get our first term, what times x squared is x to the 4th? Well, we can do x to the 4th divided by x squared, which is x squared, yes? This is the first one we've had like it that has a missing term. On our expression outside what we're dividing by, but it's still going to work. We still need that term there. We're going to distribute the x squared. X squared times x squared is x to the fourth. X squared times 0x is going to be plus 0x cubed. So I'm going to still multiply. We're going to treat it like it's an actual number, not 0. Because really x squared times 0x is 0. X squared times x is going to be x to the third. We're still going to leave it at 0. And lastly, x squared times 9 is plus 9x squared. And then we would subtract, yes? X to the fourth minus x to the fourth is 0. X cubed, 0x cubed minus 0x cubed is 0. There's two ways we can do this. One, I can't use that. I wish I could. We can write it as 0x cubed, and then we would have to do 0x cubed divided by x squared, which would be 0, which is a whole bunch of zeros, yes? So the way that we can do this also is we can go 0x cubed minus 0x cubed is 0. It's gone. 4x squared minus 9x squared is negative 5x squared, yes? So we good with this so far? Because unfortunately, or fortunately, the first term canceled and the second term canceled, yes? So that's fine. We left it as that. Then our steps would say we'd bring the next term down, yes? Well, wait, how many terms do I have outside? Well, I have how many here? 1, 2, 3 here, yes? How many do I currently have down here? But for me to divide, I need how many terms? So for me to have enough terms to divide, I have to bring a second one down. Now, I did say earlier, if the number of terms down below is less than what we're dividing by, we're done, yes? But if we look at this point, what we have down there is still a degree 2. And we're dividing it by a degree 2. We can still keep going because the degree is not less than. It has to be less than. It can't be equal to it. So we bring 2 down this time. Now we're going to say, take our negative 5x squared and divide it by x squared, giving us negative 5. We're going to multiply by negative 5. Giving us negative 5x squared plus 0x minus 45. And it will indeed be 0. So really x squared plus 9 and x squared minus 5, if we multiply those together, we get x to the fourth plus 4x squared minus 45. But what do we think of long division? It's long. It's tedious. And so are you ready for the 30 question assignment? 5 through 10. All but I think one of the 6 problems is going to have a remainder. One of those 6 is not going to have a remainder. Tomorrow we're going to go over synthetic division.